afternoon. Thanks for being here today. My name is Cesar Carmona. I work at Rivada Space Networks. I'm here together with my colleague Tarsicio Lopez, Tarsi, and we'll be talking today about the security by design approach that we're following to build up our secure LEO constellation. So this pyramid you've seen already in one of the previous presentations. So it's coming from the eBIOS risk manager methodology that we are also using, by the way, at Rivada. But it depicts the various levels when it comes to the security baseline and security risk management. So at the bottom of the pyramid, you have the basic principles, hygiene, best practices that are common to all verticals that could be applied to any kind of project, not necessarily space related. So this brings you simple protection, but well-known. Then you have, in the middle level, the regulations, the standards that may apply to your vertical. In the case of the space industry, there is a variety of them, not any of them being completely comprehensive, and some of them, attached to a certain kind of specific application or use case. And at the top of the pyramid, we have the digital risk assessment or security risk assessment, which goes the extra mile and provides, security controls for your specific use case. So the two bottom parts are related to the compliance, where the top is actually looking into the specifics of your system and on your use case. So you need to consider all of them. When it comes to the frameworks, each vertical or many verticals have its own framework. So for example, in the banking industry, PSI for credit cards and so on, we all know about the NIST, about the ISO and so on. So it doesn't mean that framework is better or worse than other. It just stick better to your kind of vertical and to the kind of business your company is in. There are some that are generic, like the NIST, but that can be or are already, personalized or customized for space applications. So in the case of Rivada, what we have selected is the so-called AA-PRE. So stands for the Infrastructure Asset Pre-Approval, which is largely based on the NIST 853 and is specific to the provision of security services to the US government for national security applications. So this is what we have selected at Rivada as our compliance framework. We are developing our system based on it. And by the way, since it's largely based on the NIST, we can make use of the well-known equivalences to the ISO, and thereby also addressing commercial users. So we'll be talking about a number of security design principles in the slides that my colleague Tarsi will present later on. So this is kind of a table of contents here. There are a lot of principles that all of you know, applicable to any kind of industry, any kind of project, not specific to space. Defense in depth, the prevention of human error, number one vulnerability, the definition of trust boundaries, least privilege, least functionalities, simple defined interfaces, segmentation, segregation, the minimization of high security zones, keeping it as simple as possible, application of the separation of duties principle, and so on. And then there are some specific aspects that we are applying and there are exclusive or relevant to the satellite projects. So like the securitization of the satellite command and control, we will have a slide on that later on. The isolation and degradation mode, and the cherry on top of the cake, the security risk management process, which is something that we are, let's say, applying on the entire system development life cycle, as you will see in a moment. So these are principles that you can look at when you are defining or when you are securing your satellite system. We find the NIST a very great source of inspiration, so to say. So for the definition of our security activities, we used quite a lot the special publication 160. So that's engineering trustworthy secure systems and developing cyber sealing systems. I actually encourage all of you to have a look at them. They will bring you a lot of interesting ideas. So I'm not gonna go into these slide in detail. This is just to show how we at Rivada are bringing in security activities across the system development lifecycle, so across the project phases A to F. So at the beginning of the project, it is all about the definition of roles, responsibilities, orientation of the staff on security, creating awareness, defining the assurance levels, defining the objective profiles, security objective profiles, and having a preliminary kind of profile. So this would be kind of phase A, and the phase B would be further elaboration on this. You can kind of establish your security objective profiles, and you start decomposing the system, establishing the security boundaries, establishing also the key information flows, exit and entry points to your system, and you start running key activity within the overall security by design process, which you will see quite a lot in this presentation, and also in the overall process security risk assessment. So identification of vulnerabilities and threats, evaluation of risks with evaluation of impact and likelihood, and lately selection of controls. So then later on, you finalize the composition of your system. You have a frozen architecture of the detailed design. You reiterate on the security risk assessment. You create test data. You test your test data. And finally, you have, at the CDR level, your security controls fully tested. Or the phase B, you go into the certification accreditation. In the case of our program, it's about proving compliance to the AA-PRE and getting the certification from the relevant authorities. You need to measure the compliance, and you need to deliver. So prior to the delivery of the system to operations, you need to reiterate on that process. So over the operations, you basically want to maintain. You want to maintain your compliance status. You want to maintain your security controls that are coming from the security risk assessment, updated and well under control. And then of the disposal phase, well, it's all about the preservation of information, sanitization, and disposal. So a few words about our satellite constellation and the different types. So type 1 constellation, this is very quick. This is what most of you know with Starlink, OneWeb, Amazon, Kuiper. It's going to be like that. So they're all based on internet gateways. So thereby the range that you can reach with that is in the order of thousands of kilometers. So you need to have through the satellite visibility of a gateway. So you cannot have global coverage with that. Type 2 is when satellites talk to each other via intersatellite links, so you can extend the range of the Type 1 to global scale, but you still depend on internet gateways. So you are depending on terrestrial networks. And our concept, the Type 3, is pretty much putting everything upside down, so bringing the entire network on the sky, not having any gateways whatsoever, so it's a completely gateway-less system. Thereby enabling the users to have full control of the route of the data from one extreme to the other. So there's a little video here showing how our system becomes gateway-less. So elimination of the gateways, direct communication between the satellites via intersatellite links using optical communications. So we will be deploying our satellites on over 24 polar planes at 1,050 kilometers altitude, creating an MPLS network for customers. So our latency performance will be less than 100 milliseconds for long-range communications, and less than 50 in the area of continental-like communications. So thereby competing directly with terrestrial lines. So I'm going to leave the floor now to my colleague Tarsi, who's going to give you more details about ideas and design decisions design options on the security by design process of our constellation.
Hello, everyone. I have 10 minutes. Yesterday, never managed to do it below 20. So be prepared, and sorry for the verborrhea. I'm going to scratch the surface on many, many topics that many other people have been addressing this year and others. So follow me. This is a very basic layout to make it possible to break it down into different parts of the system for a constellation with optical intersatellite links. In this case, gateway-less, following Rivada's approach. But if you would like to include the gateway, it would be more or less like the user terminal in terms of trust. You just have another place to repatriate or backhaul the data. Okay? Important things are to differentiate the telemetry and telecommand from and to the platform. And I decided to break it down into two parts for the platform to be controlled over a ground station network controlled by the satellite control center, and the same over the payload. So these guys from the mission control center are in charge on doing payload operations, okay? And of course, there is some kind of overlap because you need to bootstrap the system somehow, which is here, logically depicted as a way of how much do you want the payload to talk to the platform and the other way around. So you are confronted with a number of decisions when doing the design, which are very much use case dependent. The command and control of the platform versus the payload is an obvious one, because even if the money is coming, the revenue is coming from the availability of the payload, what you do not want at all costs is to lose the platform command and control. And then you have things like single and multi-users, which from the legacy systems I have worked before, you would use only one root account, able to do anything. You might have the choice to separate here what subset of commands which group is able to send to the satellite. But in terms of using a Linux on board, it's opening up the number of options. So you really need to think about that and who's having access to the satellite. I like to think about it more as if it were a house, and you need to protect mainly the main door, because you are the only one living in that house. If you can access the payload from the user terminal or from any other place, then it's a house. You need different rooms with different locks on it. We're in security, we know what we're talking about. So the ground stations is also an interesting part in the moment you start talking about ground station as a service, because it opens up the stakeholders and the entry that they have to your system and the level of trust you have to have with other ground station providers or other services like identity provider, or if you want to use a cloud service. This is another thing that it's really important. But getting back to the taxonomy of the space missions, I have tried to break it down because there is no one size fits all for a space, and excluding even deep space missions, I would like to differentiate between type, orbit, size, code, and infrastructure. Very quickly, GNSS services and Earth observation care very much about integrity and possibly availability. You would think a communication systems cares about confidentiality. I want to push that responsibility to these guys, to the users, because those are the ones securing their own data. What you want to do is to protect your system, integrity, and ensure that you make the service available. So actually, communications is about availability through the integrity that you have, because you are sure that at all times you can maintain the service, or at least within the SLA. The orbit makes it different, because we know how geostationary satellites work, and LEO and MEO are a different approach to it. Right? So Starlink has a multi-shell approach, same as IRIS². We only work at the LEO, but at sweet spot altitude of 1,000 kilometers. And we're working with many satellites, 300 at the beginning, 600 at the end. And this is where, in the goal, or stakeholders and infrastructure, things can deviate. If you're serving state members or governmental actors, they might force you to go to a kind of private on-prem cloud solution. If you're in a commercial world, you can go for a public one. So now I will try to get very quickly into the different aspects of all of the elements I have been talking about. We have already talked in other presentations about how to secure the telemetry and telecommand, but it's mostly CCSDS, STLS, and layer 2. The moment you have the ability to command the payload, or even the platform through the payload, which is another data flow you might want to consider, you are no longer in a layer 2, but in a network. And this changes things. The good things are we have experience over many years about how networks work. And one key aspect of it is how to address the management plane of the router, which is nominally on a management plane completely separated from the data plane. You do not have that here. You do not have a dedicated cable for controlling the payload that is not addressing where the user data is running through. So this is a kind of in-band management, but you need to bootstrap somehow. So those are things you want to think about when defining the governance model and who is doing what and how are you doing that. Securing the satellites. I don't want to go about all of that. Supply chain risk management is an important one because the satellite is most vulnerable during the first stages of the life cycle, when you are developing, integrating, and validating it, especially when you are at the... If you're using a symmetric encryption algorithm, you need to inject the key material, ideally pre-launch, on a secure manner, and protect those keys for the whole life cycle of the mission, because those are your crown jewel. Then, unless you have over-the-air rekeying or something of the sort, you can potentially lose the ability to control the satellite. So that's the main thing that I want to say about that. We have been changing from bent pipe approach or transparent transponders, on which the satellite is just a gateway. You don't need to do nothing with the user data, to a regenerative payload, which is working different because the moment you start processing data, you open up the surface attack. ConOps dependency is something I want to touch upon. It really changes if you are the only one doing all the stuff, if you are your own supplier for the satellite, and then you operate the satellite and you give the service. But the world is changing, and this is going more and more distributed. So one of the many key aspects that you need to take into account is how much responsibility and trust do you put on third parties for services, software, and hardware. And the ConOps is operational security relevant because, well, it's not the same being in charge of the platform, of the payload, or how the user is actually receiving the data. This is also for Earth observation, another kind of model in which you, as a user, just do not care about the satellite, you just service request saying this point in time, this photograph, and you retrieved from ground, or if you can actually tell the satellite directly. So it's about data flows, end-to-end securization, and who's talking to whom, and what level of penetration this stakeholder has into your system. Very quickly about Transec, meaning ISO layers 1 and 2. The regenerative payload and advanced capabilities of today's communications payload allow you to make the argument that without having PRS capabilities of Transec, you can still enhance the resilience of jamming situations because you have beam directivity, meaning that if you are here, the satellite is not only it's only talking to you, or cell-wide at the very least, and not like the geostationary where you just have inside the footprint of your antenna possibly the whole of the Earth. So for a jammer to have an influence on this one, you would need to be kind of aligned with the communications between the user terminal and the satellite. The low probability of detection addresses the ability to change your signal-to-noise ratio, as well as the modulation and coding that you don't want to interfere with other systems, so you adapt to the channel conditions. These channel conditions could be weather, or it could be other people, interference situations, but non-malicious, as well as malicious. So you have more options in your toolbox to address jamming. Right, about ComSec. and the user terminal. The user terminal is a special part of the element and the landscape. I consider it not to be trusted because it's in third-party hands. And we have seen the report from the researcher that managed to, by failed injection, rootkit the user terminal of Starlink. So the most important thing is the least privilege principle. To even if you are having full control of the user terminal, you cannot disrupt the service. You are only affecting the service that you are already paying for, meaning only for that user terminal. You can still add as many layers of security as you like, one of them being the authentication and ensuring a secure enrollment. So because you don't want to give service to someone who is not paying for it. Okay, user metadata protection, depending on your customers, you might not be very much interested in all the people knowing where you are, who you are, or what are you doing. So just think about it. Next. I'm going to jump over this one only to say that it's important to map the landscape. This is a wink to the eBIOS RM methodology where you have strategic scenarios. We actually had already an eBIOS presentation today. And it's thinking about how do you map who's having access to which elements and what interconnections there are to achieve whatever attack you want to realize. Okay, sorry for jumping over this one. And yes, the last one, it's just a picture. Is how do you put together the number of things. I never addressed interconnectivity before, but it also plays an important role in terms of availability of the connections of the different elements. And I wanted to highlight how is it possible to maybe considering working on a mission control center where all the processing happens in the public cloud, and how do you secure the telemetry and telecommand in these scenarios. So the first thing that you need to do is to put an end-to-end connection from the satellite control center to the satellite. If you do not trust your cloud service provider because your keys are so important, you want to have it somewhere in your control center, then you need to find a way for the telecommand to be sent in clear, but it's still secured either by IPsec or with a zero trust network access provider. But in the end, the idea is that that command gets out, encrypted, arrives at the ground station, and the ground station uploads it to the satellite. If you are addressing this satellite, then these commands is executed only after decryption. And if it's not for this satellite, it depends on what data flows and management planes have you defined for you to be able to jump over many of them until you arrive at your final destination. So it's an easy, not an easy and a very nice security problem to work on. Thank you very much. Feel free to make any questions.
Okay, now we can start with the questions.
Thank you. I saw a bullet point about asymmetric encryption, or asymmetric cryptography with PKI. You mentioned crypto agility and PKI in space. Can you please elaborate a little bit further around those bullet points?
Thank you for bringing that up. Post-quantum resistance is something everyone likes to talk about. The general agreement we have in the community is that symmetric encryption algorithms such as AES with a 256 key length is already post-quantum resistant. So the moment you want to go for an asymmetric kind of way, crypto agility is a must because you never know what's going to happen in a couple of years. This is the first thing. The second thing is I wouldn't advise to secure the platform through a PKI because a PKI allows you a many-to-many in a secure manner. And maybe your satellites do not need to communicate with each other necessarily in an authenticated and encrypted way. If it's only your control center, it's one-to-many, symmetric encryption is still managing that challenge. There are other challenges, but the PKI is definitely something very interesting for constellations, on which my take on it is not still at the level of maturity to work on space protocols. So CCSTS, STLS, PKI, you cannot put them together in the same sentence. I know there are initiatives from ESA, for example, to take a look at that. I would do it on the payload, but if the payload stops working or it's application security, you can still go from the platform, say, delete, reboot, whatever. Yeah, very quickly on that.
Next question.
Would you consider having your telecommands and telemetry using the ISL facilities so that you avoid the need to have visibility from the control center, the TTNC station, and the satellite? And does it change something from a security design standpoint?
From which facilities?
Let's assume that you want to telecommand a satellite, and then you would use the inter-satellite links in order to reach that satellite from another satellite.
Yeah, so the idea here is to use the inter-satellite link as a kind of black network mode. So the routers are only forwarding the things because they are not for itself. And then the securization happens end-to-end and source to destination. So whatever happens in between the ground station over terrestrial networks or over the space mesh does not play any role, at least in terms of the commanding that you want to address. Because you, as a control center, secure very much like in an IPsec fashion. It's not an IPsec, but you control that satellite only after arriving by many hops to that satellite. If someone changes anything in there, you have the integrity check. You just throw away the package and say, sorry, could not process it. Another different approach would be to start securization of the inter-satellite links. I have also a couple of sentences on that. And the inter-satellite link, on optical level, they are much more difficult to intercept. It's possible, but for the orbital mechanics of it all, it's difficult to maintain it. And even so, it's even more difficult to play man in the middle, because even if you're intercepting, what you're not going to change is the sync on optical wavelength to the satellite that's being talked. So I don't know how much do you want to achieve unless you want to disturb the control planes of the constellation or how the routers talk to each other, if they are unclear. But it's way too complicated for what you can achieve. This is not the weakest link. So that's something to take into consideration, but not my major concern.
Maybe just to complement on that, it's a risk management question as well. So yes, the impact in that case on the intersatellite link may be very high, but the probability is considered to be quite low.
Okay, next questions. Perfect.
Well, thanks for the presentation, first of all. My question is more focused on the user side, let's say, and how you are thinking, because you mentioned indeed that you want authentication for the user to make sure that, you know, whoever is using the service is paying, and when you communicate with another user, the communication is authentic. You briefly mentioned something about 5G NTN crypto token. I don't know if you can elaborate a bit more on the architecture, on how you authenticate user, if you do it at the link level, end-to-end. What you can say about that would be interesting. Thanks.
Yeah, again, very quickly. It's a lot of ground to cover. I mentioned 5G NTN because this is the 3GPP standards coming out, and hopefully to be the new standard that allows integrating also the radio interface and the way the users work. These open up things like embedded SIM and the way 5G handles authentication, including how the 5G core manages it all, right? We're not that yet in terms of a standardization, and that is why no matter what, the requirement should be maybe not to authenticate the user, but at the very least the user terminal, that piece of equipment, locking onto your constellation. And there are many ways to do it. It's just for you, and depending on your business case, if you want to deploy and a smart card, or it's just a password, or if something over the air after a first time enrollment process. At the end of the day, you just want to be sure that that user terminal is a legitimate one to join the constellation. Still, something I didn't say but was written, you want to be able to monitor the behavior, because if this user terminal is not behaving as it should, then it's good to be able to decommission that user terminal. It's good to be able to check the firmware signature and see if the user terminal has been tampered, that kind of thing.
Okay, next question. There's one coming. How are you approaching the routing protocol, given the satellites are changing topology quickly?
Yeah, Cesar is saying not security related. The topology is not changing so much from the core network perspective. You have different planes, and the satellites see always the same neighbor in front and behind. It changes when you talk about left and right. That's okay. And it changes the topology in terms of the customer edge kind of things, meaning the user terminal is changing the topology of the entry into the network. Definitely, the routing protocols that you use play a very important role. What I mean to say, and I'm not giving an answer to that question because that's a very difficult one, Kimberly. But the very thing, from security perspective, what you want to ensure is that this user terminal that has to have maybe a way to talk to the satellite can only talk to the satellite with least functionality and least privilege, to not exploit potentially the routing protocols or the control plane of the routing protocols.
Excellent. Any other questions? Someone has a question?
At the very end.
Sorry, a question more generally about the robustness. Do you do only satellite-to-satellite links or also satellite-to-ground links?
Not sure if I understand the question correctly. Of course, there are satellite-to-ground links when it comes to the satellite command and control, and the payload command and control.
Yes. So
are you talking about the user plane?
No, just by Rivada, what Rivada does as a product. And if you do satellite-to-ground, how do you make sure that the weather is not a problem for optical communication? It's more about robustness.
Oh, no. We don't do optical communications to the ground.
Okay.
The air-to-ground interface is RF.
Okay, thank you.
All right. Thank you very much for another great presentation.
Yeah, come and meet us outside if you have more questions. Thanks a lot for your attention.